So next we're going to do 6.8. So the average winter low temperature in winter in Montreal is around minus 13 degrees Celsius. However, far enough below the ground, the temperature can remain above zero and reaches around 10 degrees Celsius. If you want to design a heat engine using this difference in temperature, what will be its maximal efficiency? All right, so you read this question and it's like, well, they only give us two tiny pieces of information. What are we supposed to do with that? They don't tell us about work inputs or outputs. But if you read carefully, it says, what's the maximum thermal efficiency? And this is hinting at you want to find what we call the Carnot efficiency, which you either recently learned or will be learning soon. Now, the Carnot efficiency, let's just review what it is. Carnot efficiency is what you get when you take any cycle and you idealize every single process to the maximum that you can possibly idealize it. And what you end up with is obviously a relatively high thermal efficiency. Now, the reason we have the Carnot efficiency is because the Carnot efficiency itself is always going to be less than 100, right? But it's the upper limit that we can actually reach. So the question we just did before, we saw 50% thermal efficiency. And in our heads, subconsciously, we're comparing that to 100. And we're saying, well, that's not very good. 50 out of 100, not really good. But it's not really fair to do that because even the most ideal case, the Carnot efficiency, and we'll see, is never even 100. So if we want to make a fair comparison, we have to always be comparing to the Carnot efficiency. So the significance that the Carnot efficiency has in engineering is that it allows us an actually more reasonable upper limit of how efficient we can be. So let's say in the other problem, we find the Carnot efficiency to be around 60 or 70. Well, wait a second, 50 out of 60 or 70 isn't as bad as 50 out of 100, right? So we see it's actually not so bad. Like I was saying in the other question, 50% efficiency for a steam cycle is really not that bad. So anyways, with regards to the Carnot efficiency, what you'll find is that it really only depends on the temperature limits, being how hot you add the heat and how cold you reject the heat. And the way it depends on this is that the bigger the difference, the better efficiency you have. So you want to maximize this difference. This is why in a heat engine of any kind, it's desirable to make the combustion chamber as hot as you possibly can, because that's going to increase the Carnot efficiency and it's going to let you be even more efficient. So enough talk, let's do this. It's very simple. Carnot efficiency, one way of expressing it is 1 minus the coldest temperature over the hottest temperature. And you see, of course, that if the difference is really big, if the cold temperature is really cold and the hot temperature is really high, then this ratio gets really small and we start getting very close to 1 because it's 1 minus a tiny, tiny amount. But in the case where they get really close together, well, now this fraction is getting pretty high and we're going to have to subtract a lot more in our efficiency. And again, this is the Carnot efficiency. We can never reach it. We can just get infinitely close to it. But the point is, if the Carnot efficiency is already really low, then we know we're never going to, no matter what we do, it's impossible for us to have a very efficient engine. So in this case, 1 minus, since it's a ratio, we have to look at the actual Kelvin values. So 273 minus 13, we get 260. And 273 plus 10 is 283. If you calculate this, you get about 0.08. Now that means that even in the best possible case, with everything going exactly the way you would want it, the best you could get is 8% thermal efficiency. So if you thought in the other question 50 was bad, well, now imagine 8%. It's like there's no point even. And that's just because you can see that these temperatures between minus 13 and plus 10, it's a 23 degree Celsius or 23 Kelvin difference. It's really not that much. Like compare that to a boiler or a combustion chamber in a Brayton cycle, maybe operating at 1300 Kelvin, it's and rejecting into a relatively cold environment. It's really, this 23 degree difference is really not that much. So we don't expect the Carnot efficiency to be very high.